Here are 9 Rust best practices I'm using when building a library. And we will use a Real library, genai, as an example. The first best practice is about the module structure. If we go to our lib here, we can see the following structure that I have. And so I'm using the module system of Rust for 3 different purposes: for namespacing, scoping, and code organization. So let me explain. So first, here's the namespacing. So what we have, mod support and webc, and that will mean that in all of my application code, since those modules are private to the crate, I will be able to access those. Then at the bottom, I have the public module, which is going to be exported in the API. And so that I'm using the scoping to scope it public, and here those are scoped crate in this case. And then I'm also using the module system for code organization, meaning that mod client, the common and the error from the best practices, we're going to see that later, I'm flattening them out. Because in fact, I do not need the user to have genai : client : client. So what I want, for example, is I want to have let client equal genai client default. So that is what I want to expose. Now I could have said, well, I'm going to have client, but that will be unnecessary. It's kind of weird because anyway, my client is the entry point of the library. So it wouldn't really make sense. I mean, I could, but it would be redundant to have that. So I like to have these kind of things like that. However, as we can see here, I'm exporting some sub-modules. So the chat, for example. And that is because my library might have multiple kind of capabilities, one of it being chat. And so in this case, I want to allow the user, for example, to do a chat request equal genai, and then I have chat request. And then default, for example, here I implemented default as well. So this way, now I'm kind of namespacing my chat request within this namespace. And for the client, I didn't want to namespace it, I want it to be in the root. So that is my design here, my code design for the library ergonomic. And the way that I accomplish that is by flattening. Because what I don't want is all of this code here of client. I don't want it inside the libs just for the sake of it because I didn't want to have a sub namespace. So that is basically I'm using the module system for code organization. And in fact, if we go to the chat, I have the same strategy. If I go to module, I can see that I have all of these different sub-modules, but I flatten them all. Because again, I do not want and I do not need the user to go through all of the different sub-modules just because I wanted to organize my code like that. But at the same time, I didn't want to have all the code below. So I'm putting them in files like that with a little bit of convention here, and then I flatten them out. And the naming here, if I want to change it later or reorganize it, it doesn't matter because anybody using these module types will be using it in a flat manner. So this way I can change them. And obviously, if I wanted to take mod tool and to say, well, I want the tool to actually be a submodule, I could have done it like that. I might do it one time, and that will be chat : tools. So that is a pretty powerful way of using the Rust modules to be able to either have namespace and or code organization. Now, on the scoping side is even get fancier. Because for example, if I go to the adapter, and here I use the same pattern here, a little bit more advanced. So I have the mod support, we'll talk about that later, but then I have my modules over there, and I'm going to re-export some of them in a different scope. In this case, it's private, all the adapters. I don't want them to bleed outside. I don't want the client, for example, to know the internals of the adapters, but I want the adapters and the adapter dispatcher over there to be able to obviously call them. So that's why I put them there. And the rules in Rust, again, is every children and grandchildren of a module can see everything that his parents can see. So that is basically meaning that it's going to be accessible to all of these submodules. But then after, these two guys, the adapter types and the dispatcher, are putting them crate because the client needs them. So this way here, I'm using scoping to really kind of encode my intent inside my code design and to make sure that everything makes sense. And at the beginning can be pretty loose. And as I mature my code design, I'm going to add them to make sure that everything makes sense. And in fact, if we go to the adapters, the OpenAI adapter, which has the implementation over there of the trait, and then the streamer and so on, is used by the Olama for now and for Grok. So actually, if I go to the adapter implementation, I have the implementation of the adapter trait here, which is internal things to make sure that I can reuse the logic across them all. And then I have some utilities that other adapter can use that I also put in the struct. I could have put them as function, but then I scope them relatively precisely. And so, for example, this one here, I say I only want the adapters to be able to access it. It's not something that I want to bleed outside. I could have done pub create, and that for a user of the library, it will be exactly the same thing. They won't be able to access it. The reason why I do that is because I validate that the code design works as I intended. And so that is what I have over there. And then this one, for example, I just say pub super, which means that that will be something that can be used at the OpenAI only, and others won't have access to that. So that is an example here of how these kind of things work. And so that is the scoping, and in Rust, we can get pretty deep on how we want to scope, which is pretty cool. And again, you don't have to use it at the beginning. You can just say pub create, and then you can narrow it down as you go along to really make sure that your code design makes sense. The second best practice is about the error handling. And I already done an error handling best practice. And here I'm going to show how I'm using this best practice in the genai library. So for this best practice, we define the module error. So we put all our error inside the error.rs. And then we are flattening them out. Again, error and result. And that is because I do not want to have something like genai error. That would be kind of redundant. So what I prefer to have is just error like that. And then I can do the match and everything, so it's much cleaner. And actually, we have another type of error as well for the resolver. And so that is like that, because again, I don't need to have the error module name. That's again, a good use of the flattening capability of the module system. Now, if we go to the error file, so we have our error enum, and we have our result type alias. That is a personal preference. I like to log the result type into T, and then hardcode in a way the error to be the error of the module. So this way, when I look result, I don't need to give the error, and I know it's always the error of the modules that I'm using result from. That is what I like to do. But there's another approach to just use a normal result and with the error of the crate. The most important is to get the error right. Then for the error, I typically like to have enum. Sometimes I have a struct and enum inside, but typically I start with enum. And then I have error, which is the name. I implement the debugs. That's very important. We're going to see why later. And then I have the from. And here I'm not using this error by design, because actually I'm using the derived more from. So I'm using the beta version, which is very stable. It's been very old for now. So this is very stable. And that allows me to split the display from the from. So like this, here I'm removing the from boilerplate, but I'm taking control of the display. And the trick is that the display, and that might look ugly for some, but I think is actually a good approach, is that I'm wiring the display of the error, which is kind of a requirement for error, into the debug. This is why I have the debug over there. And the reason why is because I want my error enums to be as explicit as possible. So I don't need to add English. However, my English would be broken English anyway. And anyway, you don't want the English of a developer going to the end user. So when you are doing a command line, that is definitely fine. But when you are going to do a library that is going to be used somewhere else, the people that are going to read the message anyway are going to be tech people, DevOps, or even developers. So in this case, what we want is that our enums and their data are as explicit as possible. That is a key here. It doesn't have to be clean English, but it has to be very explicit for the domain of the library. And that removes a lot of redundancy of having some sort of display here that often we don't keep in sync with the rest, and we are putting too much meaning over there. And sometimes this is not really meaningful, and we need to have the display to get the meaning of the content, which is in my case more of an anti-pattern than saying no English, just structure. And then making sure here in model info, I have the model name and I have the adapter kind. Here I have the actual role. So everything can be very, very clear. So that is what I do. Now, the second part here, which is a little bit counterintuitive, is that, and actually I did the error in the release 0.13, and I reverted it back in 0.14, which is those errors are actually today triggered by the adapter. So usually that might be a sign to say, well, those should belong to the adapter, and we'll have an adapter error and everything, which is fine. And it's actually what we have for error. We have mode, and we have an error here. It's completely fine. But the trick here is when I did that, the thing I didn't realize is I was exposing internal responsibility into the external API. Because in fact, the chat request has no messages. Today, the adapter is checking it, but tomorrow the client might be checking it. So saying that is an adapter error will be kind of wrong. In fact, many of these things here could be adapter, but actually they are more at the library level. So typically the way I start it, I always start with an error at the root of the library. I do my enums. I make them as explicit and clear as possible. I don't worry too much about the naming. I'm trying to be consistent over being proper English, but I'm trying to make them such as they can stand by themselves. And then eventually, as the code grows, I can see what should belong to another submodule. So for example, one very clear thing here was a resolver, and it makes sense that he has his own error because it's one thing that the user can override. So like this, they have a clean error to respond with. And also we have some errors in our support here, which is in our value extension, the extension trait, but that will be for another video. And if I were going to do a command line is good to have the display. I will actually use the derive more, have the display, and have the display over there from derive more. And then there's a macro which is similar to this error, which will be display. So it's not about being dogmatic of never going to have a display. It's about not defaulting to it and then adding it when it's needed. Okay, so that will conclude the error part of the best practice. And now we can go to the third best practice, which is the constructors and builder best practices. So the way that I like to split it is the constructors patterns, the setters, the chainable setters, and the builder. And that is because not every type that might benefit from chainable setters needs to be builder. So let me explain. So first here, if we go to the constructors level, if you have a type which is relatively simple and can be built without any argument and is infallible, then implementing the default is often the best option. And that is because it's very idiomatic to Rust, as well as many of the Rust libraries and other libraries are using the default implementation in their own APIs. So there's a lot of benefits to provide that if that makes sense for the type. So for example, in genai, we have a chat request, and then we have a default. And that will build a blank chat request, which might make a lot of sense. Then the next pattern that I'm using is a new. And that is when there's an obvious data that could be the starting point of the type. So that will be a new, and that will take one or more data, usually one or could be more. And then as a good example in the genai will be the chat request, new, and then it will take a vector of chat message. So that is a clean pattern, and then obviously there can be only one here. So in this case, my chat requests make complete sense to have the vector of messages. So that fits very well. So when we need multiple constructors, we do a from and then something that will make sense. So for example, in our chat request, we have a from system, and that will add a system into the chat request, not even as a message, as a system property, which is support both. And then last is we have our custom name. And those are more the exception than anything else, but sometimes it can make the API much better. So for example, rather to have a chat message from user role, I guess it would be something like this, and then white guy red, that would be a little bit long, and while dogmatically correct, probably, in this domain for chat message, it actually makes a lot of sense to have user, because then we can have the user message, the assistant message, and then even the system message. That is really fitting here. So again, making a little exception in the context of a chat message, because that is really fits very well. So the goal here again, as generally with coding, is to be disciplined and consistent. However, not being over dogmatic when some things really fits very well. And so this one here, when you see something like that, the user automatically understands that that is a user message with this text. There's no ambiguity here. It's very clear. So clarity first. Now, the next type of constructors that are also very important in some cases is to implement the right from, and that can help a lot the ergonomics of an API. So for example, in our case here, we have a type which is model name, and obviously we have the implementation from string for model name, and that will do the right implementation. And basically model name is like model name arc str. So that allows to clone it very efficiently because it's cloned many times and so on during a request. And so that makes it efficient, but we just can do a into, and that works well. By the way, sometimes you can be a little fancy here. So you can say a T, for example, into string. So like this, we do not have to implement the ref str and everything. The problem of that is that that is called a blanket implementation, and that might conflict sometimes. So if model name can be a into string as well, which is in our case it is because we implemented display for it, you will get a compiler. So sometimes you cannot be over smart with blanket implementation. So what you do here is completely fine. You will do the string, and then if you need it, you do the ref string and the ref str or whatever technique you want. And that will allow you to cover most use cases, a little bit more code, but that will work well as well. And you have a better control. So that is what we have done here for the model name. It goes both ways. Now, for the setters, the way that I like to do it is to have a pattern like this, which is with. So that is my default go-to. And I like the consuming chainable setter patterns. And you can do the ref mute as well. Depends on how you want to do your API. And then you take usually one, could be multiple, but usually it will be one. And one example in Chat AI is once you have a chat request, we also have a with system, and you can put your system like that. So this way you can start your chat request like that, and then add the system after, or do a from system. And then what we have, it wouldn't be with messages, it would be weird. So we use the append. You could use a push as well, and that will be consuming as well. And for example, that will be a chat request, append message, chat message, user, y, sky red. So now things are starting to fit together here where we have the constructor pattern, which makes sense over there. We have our setters that can be chainable and so on. And then sometime also I have another naming convention where it's more like a key value pair. I do an insert, and then I will do the self, the key, the value. And in the genai, I'm using that for the client builder. And we have an insert adapter config. This is adapter kind, and this is the adapter config. So that fits very well here, like that. And by the way, the cool thing as well is because we have implemented the right from here, we have a type in genai, which is a message content. So here we have the feeling that we're giving always a string. So in the system is a case. But for the chat message of user, this will actually implement something like that. We'll have the content and we'll have import into message content. And the message content has a from, string, and so on. So that's why it works. And that will allow us later, today we only support text, but then we will support images and everything. But then we don't bug the user of the API to have to build a message content and all this kind of thing. They can if they want, they can pass it through, obviously, or they can use any type that has a from, and that will work as nicely. So obviously that will add a little bit to the size of the binary, but the net value is huge, so we don't have to worry too much about that. So now let's go and talk about the builder. So first here, the thing very important to note is that builders are not needed for all types. It's not because a type has some sort of chainable setters that suddenly we need to have a builder. Sometimes muting in place is plenty enough. And moreover, Rust has these things with arc and reference, which you can decide when your type is mutable or not. So for simpler type, for example, in our case, the chat request, the chat message, we don't need a builder. We can just mute them in place and then pass them as a reference if we don't want a function to mute it, put it in an arc or whatever we want. Now, where a builder pattern is very useful is when the target type, which is the thing that we want to build, is immutable, shared. So arc inner something. So for example, usually when you have a client of some sort, where you want to build the client once, like a web client or like in our case, a genai client, and then you have resources that are quite expensive to build and maintain or has some sort of inner immutability. So when the target T, is completely immutable and it has benefit of that, then the builder is very appropriate. There might be other cases, but that is a good use case. So in our case here, typically what I like to do is be very dumb and simple to suffix it with builder. So in our case, that would be client builder, for example. Then obviously we have the build function, and sometimes might return T or result of T if we need validation. So again, the goal here is not to say all builder need to resolve T or all builder need to return T, is we need to be specific to the domain, to the libraries that we are building. And if something is infallible and will probably be infallible in the future, then it's okay to just have the build returning a T. Yeah. Now, sometimes you have a type T that requires some validation and everything and should be validated before building. And in this case, you will return a result of T. That will be valid as well. And it's the same rule here over there. Usually you will return self, but sometimes there might be some use cases where you want to return a result of T. The same thing for the constructors here. You might want to return the result of T. And sometimes, again, this constructor might be async. So here is a simple use case, but sometimes you might want them to be async for whatever reason. But when you can avoid it, it's always better. And then here we have the same setter patterns that we have above. So exactly the same thing. So for example, in genai, we have a client builder, and we have the ability to have the user set their own request with client of the request library. And then here you give your own request, which you build with a request builder as well. And then obviously you can use any of these patterns here. For example, here we have our client builder, insert, adapter config. Yep. So that is the thing. Now there's another little trick that I like to have, and that is really kind of a personal preference, but I like it. I like to have my T, so in this case will be client builder, and that will return the builder type of the type T. So that will be in our lib here will be the client builder, and that will return this one, and then we can set, and then call build, and that will return the client. And that is just like a very cosmetic, convenient kind of thing, such as the user doesn't have to import the client builder and can just do everything from client and then build at the end. So that is just a convenience kind of things. This is really kind of a personal preference, doesn't cost anything, simple and very clear from the naming anyway. Okay, so that is the way that I'm doing it. And we can see it a little bit on the code right now. We're going to do a quick code review to see how things are implemented. We're going to go to our chat, and again we have our module, and here I'm flattening everything, such as I have all my mode, but everything is flat because I don't need to expose my code organization. And then right now I decided to have everything which is related to chat request inside the chat request module. And then I like to have this code region. Eventually that might be split into different files, but again, it wouldn't matter to anybody else because it will be flattened anyway. And so if I go to the chat request, the way that I like to have it is to have first the type. So in this case, I implement debug most of the time. The clone, because it's nice to be cloned and you need to have clone, which when you have conversation, obviously. And then we have the default. So it makes sense here for this object to have the default, and the default is simple enough because everything is either option or vector. Here I didn't wrap the vector into an option, which sometimes is a technique to kind of make it a little bit more performant. But anyway, a chat request will always kind of have one message because it will usually be at least one. And then I like to have different block, implementation block for the different things. And that is a cool thing again with Rust is we can have different blocks and it's exactly the same thing as if there were one implementation, but this way I can split them without having the code region. So that's my way of doing it, personal preference. And then if I go here, I can see that I have the new here, which is just the vector message. And that just do something like that, very dumb. And then the from system that will do these things. And then I'm putting the system here in the system property. And then I have my message later. And then I have my chainable setters. And so again, here we have the with system, which just set the system or override it. And then we have the append message, which just push a message. And then I can have append messages that will take a vector of messages, and then we'll do an extend. So I can add as I go along. And then in this case, I also implemented some getters. That is another best practice. And the reason here is something pretty neat that I need to do is, in AI, you need to combine the system of the chat request with the eventual system messages as well. So that is the way it works. And so in this case, I have an iter system that is basically chaining the option of system with the vector, the iterator of the messages. And so that will give me one iterator with everything. And then I have this guy here, which does a little bit of cool stuff, which is trying the best to add a new line in between the system. So it's going to look at the end, and then it's going to try to do a best effort of adding a new line. So again, this is what I'm using in the adapters, and then I decided to expose it for the end user as well. It's pretty neat. So this one uses that one, obviously. And then if we go to the chat message, that is a good example here, we have the same pattern. I have the chat roles, the content, and the extra. And then we have the message content. So all of the constructors here take import into message content, and I have the from, string, str, and so on. But right now, the message content only support text. But the goal here is that later it will be a multi-part as well, such as you can send images and everything. But the cool thing, again, in the message content is I have all of the from for this guy. So that allows me to do that and to provide a very convenient API to the end user. That is the reason why. And then that's it. And then on this one here, I didn't really need to have any kind of setters, because usually you create with the constructors and you can set the thing manually. Later, I might have some kind of setters for the extra, the tools or whatever, but that will come later. So right now, I have that. And then that's it. And that will conclude this episode. And in the next one, we'll talk about other best practices, the util, support, and extension trait, test and examples. And then we'll do when to async and not async, project files, and versioning. Hope you liked it. Big thanks to Crab Nebula for their sponsorship. Until next one, happy coding.